Hello, Matt. How are you today?
Hello, I'm good. How are you?
Not bad, thank you. What did you prepare for us today?
Today I'm going to be talking about mainly Knative, an open source project to run containers in a serverless way. And then I'm talking about the eventing aspect of Knative, so how to build event-driven applications using Knative.
Sounds great. Okay, so the mic is yours. Welcome to start.
Thank you. Hello, everyone. My name is Mete Atamel. I am a developer advocate at Google. And today I want to talk to you about event-driven serverless architectures with Knative and Cloud Run. Now, before I start my talk, I want to let you know that I write about these topics on my blog at atamel.dev, and I tweet about them as well on my Twitter account, so feel free to follow me. And also the presentation is already on Speaker Deck, and here's the link, so feel free to get the presentation as well. I'm also going to be showing demos throughout the presentation, and they're all open source and on GitHub, and I'm going to share the links of that as we go through the presentation. Now, as I mentioned, this talk is about event-driven service architectures with Cloud Run and Knative. But before we get into the event-driven part, first I want to talk about serverless and containers in general. Then I want to get into what is Knative as a project and what it tries to do. Then Knative has two separate parts, Knative Serving and Knative Eventing. So I want to mention the Knative Serving element and just show you a little bit about that, because without that we can't really understand the eventing part. And then finally we'll get into Knative Eventing and then look at what Knative provides for you to be able to write event-driven architecture. So we're going to start building towards Knative Eventing. And towards the end of the presentation, I will show you an app that I built during the lockdown. And this app uses all parts of Knative, the Knative Serving, Knative Eventing, and hopefully that will kind of bring it all together. So that's our plan as we go throughout the presentation. Now, first, let's just talk about serverless briefly. Of course, depending on who you talk to, different people have different definitions of serverless. But actually, you can think of serverless in two different ways. The first way is the operational ways of thinking about serverless. Like, so how do you actually run code in a serverless way? And when you say you run the code in a serverless way, you basically usually mean that you don't have to worry about infrastructure. So you don't have to set up servers. You don't have to worry about the security of those servers, blocking the ports and things like that. And then you only pay for the time that you're using your service. So for example, if you deploy the serverless function, you only pay when people use your function, but you don't necessarily pay all the time like you would on a server or like a virtual machine. Another way of thinking serverless is the programming model. So when you're building serverless services, you usually mean services. So we are not talking about background jobs or big data processing or anything like that. They're usually service-based services that are usually triggered by an event. So this event could be an HTTP trigger, but it can be other things like pops up messages or cloud storage events and things like that. And usually these services are stateless because these serverless frameworks or services, they are elastic, meaning they scale down to zero when no one uses them, so you don't have to pay. Then they scale up when a lot of people are using them. So when that happens, if you don't have the state, it's much easier to scale it up and down. So that's why this state is usually external. So that's what we usually mean by serverless when we talk about serverless things. At the same time, we have these other things called containers. The whole premise of containers is that you have your application. Your application has some dependencies on other libraries, and your application has some environment needs, like for example, it needs certain ports, things like that. And you define all of this, your app dependencies and its environment into what's called a container. And then this container, it's basically a context that you can replicate on different environments. So whether you run the container locally on your machine or whether you run it in the cloud, you can rely on this context. So because of this, containers became really popular because it gives you this replicatable context that you can run anywhere. It gives you a lot of flexibility, so you can choose any language you want, you can choose any library you want pretty much. And there's this huge ecosystem around containers where there are things like Kubernetes to manage containers. There's Istio to manage the traffic to your containers. There's other projects like Knative that we're going to talk about to run containers in a serverless way. So that's why containers became really popular. Now, when you look at it, up until recently, we had to make a choice from the beginning, right? If we start a project and if we can use a serverless service from a cloud provider, like Google Cloud Functions or AWS Lambda or Azure Functions or something like that, great, we can do that, and that will give us a lot of velocity because we have a lot of things that's done for us, so we don't have to worry about the details of how to run that service, how to scale it and things like that. But at the same time, as soon as you run into a problem with that framework, you had to fall back to containers. And by problem, I mean things like the things that are supported. For example, if you want to run a certain language, like I don't know, like Rust or something else, maybe that's not supported in the framework that you want to use. So then you can use a serverless framework for that. So what people did is basically they went with serverless when they can, and they get the velocity with the serverless. But as soon as they cannot use it for whatever reason, then they will fall back to containers. And with containers, you get the flexibility, but then you kind of lose the velocity of serverless. So this was a really unfortunate choice that we had to make. But thankfully, the projects like Knative and Cloud Run, they try to kind of get rid of this choice so that you don't have to make this choice yourself. Knative, it's an open source project that was started by Google, but now it's fully open source and a number of companies are contributing to it as well. And the whole premise of Knative is to bring serverless to containers. So usually when we talk about serverless, we talk about serverless functions, but Knative tries to give you a way to deploy containers, but in a way that's serverless. And we'll talk about what this means as we go along. So that's Knative. It's open source. It runs everywhere there's Kubernetes, whether you run it on-prem or in the cloud. You can use it anywhere you want. But if you are running in Google Cloud, there's also two flavors of Knative called Cloud Run and Cloud Run on Anthos. These are managed version of Knative that Google provides. For example, Cloud Run, it's a fully managed service that implements the Knative API. So if you're already on Google Cloud, it's probably much easier to use Cloud Run instead of installing Knative yourself. And also there's something called Cloud Run on Anthos, which is a version of Cloud Run that runs on Google Kubernetes Engine. So if you want to stay in Kubernetes ecosystem, but you want to be in Google Cloud, you can use Cloud Run on Anthos as well. In today's talk, I'm mostly focusing on Knative because it's the open source version that runs everywhere. But most of the things that I'm going to talk about, they apply on Cloud Run as well. So you can run them easier with Cloud Run if you're in Google Cloud. But we'll focus on Knative in this talk. All right, so what is the Knative stack? Well, first of all, you have Kubernetes at the bottom layer. So that's the platform where everything runs. Then on top of that, you need to install a gateway. So Knative, it doesn't try to solve networking problems, right? So it doesn't try to figure out how do you get traffic from outside to your containers. Instead, it relies on a gateway like Istio or others that you need to install yourself and configure yourself. And then once you have Kubernetes and Istio installed, you can install the Knative components. There's two components of Knative. One is Knative Serving, the other one is Knative Eventing. I'm going to show you Serving, but our focus will be more on the eventing side. And then at that point, you can use Knative if you want. But as I mentioned, if you're in a cloud provider like Google Cloud, you might want to look into Cloud Run or Cloud Run on Anthos. And other cloud providers, they have their own implementations as well. So you might want to check what else is built on top of Knative to use that instead, because it will be easier. Now, let's look at the first part of Knative, Knative Serving, so that we understand what that does, and then we'll get into eventing. Knative Serving, in a nutshell, it tries to give you a way to deploy containers so that it acts like a serverless framework. And what I mean by that is that normally when you want to deploy a container on Kubernetes, you need to create a pod, then you need to create a deployment, Kubernetes deployment, then you need to create a Kubernetes service to expose the deployment to the outside world. Then if you are using Istio for traffic management, you need to create a gateway to enable the port. Then you need to create a virtual service to connect the gateway to your Kubernetes service. So there's a lot of things that you need to do to get a container up and running. And then you also need to worry about scaling the container up and down, stuff like that. So it's not that easy. Whereas in Knative serving, what you do is you create a Knative service and you point to your container and you say, okay, this is my container, it's deployed on Docker Hub or Google Container Registry. And then Knative serving takes care of the rest. It deploys your container in a pod, but you don't need to define the pod. So it does that for you automatically. Then it configures the traffic so that the traffic goes to your pod. Then it sets up automatic scaling. So your pod automatically scales down to 0 after 60 seconds, and then it will scale up to n that you define. Then on top of that, you get configuration and revision management. So every time you deploy your container, you get new revision, and with that new revision, you can, if you have multiple revisions, you can do traffic splitting, or you can roll back to a previous revision. So in a nutshell, it gives you a much easier way of deploying a container, getting that container auto-scaled, getting the container traffic managed, getting its traffic managed, and then you also have a really easy way of getting some kind of revisions and traffic splitting with those revisions. Now, the Knative serving terminology is basically you need to know four things with Knative serving. At the top level, you have Knative service. This is separate from Kubernetes service, by the way. It's a higher level API, and it's a Knative service, and I'm going to show you some examples of that. So the service will have a configuration where you point to your container and other things like environment variables. Then you deploy your service and configuration, and that creates a revision, which is a snapshot of your current service and configuration. And then Knative also creates a route for you that points to that revision. So by default, the route goes to the latest revision. But then once you deploy multiple revisions, you can change this route to do traffic splitting, right? So Knative service at the top layer that has a configuration. With that, you get a revision, and then you have the route to point to that revision. And then you can do complicated routing if you want by changing the route definition. So let's actually look at some examples of this so that you know what I'm talking about. First of all, I want to point out that I have a GitHub tutorial called Knative tutorial, where I have this presentation, and I also show you how to install Knative. And then I have a lot of samples on Knative serving, Knative Eventing, and also Tekton pipelines. So feel free to check it out. So I'm just going to show you some examples from this tutorial, but if you want to come back, this is the link for it. I already created a Knative cluster. So as you can see, I installed a Google Kubernetes cluster. I deployed Istio on top of that, and then I installed Knative 0.16, which is almost the latest version of Knative as of today, and I already configured it. So let's just double check that actually our Knative components are running. So if I go to my console, if I do kubectl get pods, and Knative gets installed into separate namespaces. So if I do Knative serving, these will be the pods for Knative serving. As you can see, they're running. And let's also make sure that Knative Eventing pods are running as well. Yeah, so everything is up and running. So we're ready to deploy our first Knative service. Now, in this first service, what I want to do is I want to write a service where when it receives a message, it will just say hello world with that message. So it's something very simple. Just to show you the code briefly, and this is, as I mentioned, this is all on GitHub. I have the code in C#, but you can write it in any language you want. So in this C# code, I am handling the GET request. When the GET request comes in, I look at an environment variable called target. If it's there, then I'll just say hello target. Otherwise, I will just say hello world. So the code is very simple. I create a Docker file for my container, and I built and push my image already. And then for the service definition, we create service v1. So this is the first definition of my service. And in this definition, you can see that we are using Knative service, Knative API. So this is a Knative service. The kind is a service. The name is hello world. and then it will be deployed into the default namespace, but you can choose other namespaces if you want. And this is a definition, this is a configuration of my service. In this configuration, I am pointing to my Docker image that I pushed before the talk, and then I'm passing in the environment variable target v1, right? This is all I'm doing here. So let's deploy this and see what happens. But before we deploy, let me also watch something. So I'm watching Kubernetes pods, KtoService, Knative configuration, Knative revision, and Knative route. So all the things that I talked about, I'm watching. Right now, there's nothing right now. But now let's deploy the first service. So I'll just say kubectl apply service. Oh, sorry. Service v1. Now we are deploying the first version of the service. You can see that right away, Knative realizes that the service is deployed. So I have my service created. I have my configuration that's been created. A pod has been created and it's running, so I don't have to create the pod myself. The revision is being created. This is the first revision of my service. And then we also have a route that was set up to point to the revision. And Knative comes with a dummy nip.io domain that I set up, so that I don't have to set up a fully configured domain. But now if I do a curl to that URL, you will see that it says hello v1, right? So our service is deployed, which is really easy. Now, if I want to do an update to the service, let's look at the second version of the service. In here, I am doing the same definition. I am using the same container, but I'm changing the environment variable from version 1 to version 2. So I'm doing a configuration change. So that's a change in the service. And then in the third version of this service, I'm doing something else. So I am changing the image from version 1 to version 2, version 3. So in this image, I'm changing my message from hello to bye. So I'm doing a code change. And then I'm also changing the environment variable from version 1 to version 3 as well. So I'm doing a couple of changes here. So let's imagine we do these changes and let's see what happens. So let's first apply the service v2. So this is the configuration change. And you can see that Knative immediately realizes that this is a new configuration, and it created a new revision for it, and then it created a new pod for it as well, and that pod is running. You also realize that the previous pod is terminating because we haven't used the version 1 for 60 seconds, so it's scaling down, right? That auto-scaling is already set up for me. Now, if I do a curl again to the same URL, you can see that I see hello v2. So we did a configuration change. Now, in the version 3, let's deploy that as well. Remember, we did in version 3, we did more. We did a code change. We use a new container, but we also did a configuration change because we passed in version 3 as well. Now, in this case, again, the revision is updated to revision 3. We have a new pod running, and if you do a curl again, now it says by v3. So we did a configuration and code change as well, and we just deployed our new code. So you can see how easy it is to deploy new versions and get traffic sent to those revisions, things like that. As I mentioned, you can do traffic splitting and things like that in Knative. So let's look at an example of how to do that. First, what I want to show you is that you can give your revisions a predictable name. So for example, in here, you can see that our revisions, they have random names, like it's always hello world, but the name itself is dash something random. But you can actually change that. So if you go to your service definition, and then you just pass in this metadata name, you can name this revision. So right now I'm saying I want to name this revision version 1. And I'm going back to version 1 on my service. And then I'm also adding a traffic rule here. So I can change the traffic as well. So what I'm saying here is that I want this traffic rule where the current traffic will go to this revision that I just defined here, and it will be the 100% of the traffic. So all the traffic will go to this revision. And then I'm also defining that anything else will get no traffic. So if I deploy some other revision, it won't get any traffic. That's what I'm defining here. Now let's deploy this. So I'm deploying back service 1, but it's with a name. So the difference in this case, you can see that we deployed it, and then now we have a predictable name for our service. This is the version 1. And then if I do a curl again, you will see that now the pod is being created because we scaled down, but now we are still going to version 3. But if I do another one, we are back to version 1. So we are back to version 1 with a predictable name. Now let's deploy a version 4. Now in the version 4, I am deploying the same container, but I'm passing the target version 4, and I'm keeping the traffic rules the same. So the traffic still goes to version 1. So what I'm going to do is I'm going to deploy version 4, but it won't get any traffic. So I'm doing a silent deploy actually. So let's do that and see how that works. So let's do version 4. And now we can see that I have the revision 4, version 4 that's been created. It also has a predictable name, and the version 4 pod is also being created. But if I do a curl to the same URL, it still says version 1 because we specify that version 4 should not get any traffic, right? So that's the difference here, is that version 1 is deployed, version 4 is deployed, but version 1 is the one getting the traffic. Now, if I go to this URL and then change this URL and add this latest dash at the beginning, now you can get to version 4. It says hello v4. So I did a silent deploy. I can test that silent deploy by going to a special URL. And once I'm happy that this version works, I can upgrade my traffic rules and let it get traffic. So imagine, let's say, you want this to get 50% of the traffic. Then all you need to do is you can go to your service and then just change the traffic rules of your service and say, okay, I want version 1 on my traffic to get 50%, and I want version 4 to get the other 50%. And anything else after that, let's say we have a version 5, it won't get any traffic, right? So that's what we are trying to do here. Let's do this as well before we wrap up the Knative serving. So I'm going to do version 1, version 4 split. So now we are not creating anything new here, so there's no new revision. All we are doing is that we are updating the route, right, to do traffic splitting. Now if I do a curl again, it says hello v4, add a curl. Now it's scaling version 1 up, and it says hello v1. So it will roughly be version 1 and version 4. So this is Knative serving. As I mentioned, it gives you a very easy way of deploying containers and kind of configuring traffic to those containers. And once I'm done, I can just say kubectl delete Knative service, and let's say hello world. And now the hello world service will be created, and everything about the service will be deleted as well. All right, so that's Knative serving. Now, the second part I want to mention is Knative Eventing. And Knative Eventing, all it tries to do is it tries to connect certain event sources to event consumers with certain delivery methods in the middle. So it tries to kind of connect different kinds of event sources to different kinds of event consumers with some kind of control in the middle that you can define how those events will flow in your system. These event consumers, they are usually Knative services, but they can be Kubernetes services as well. And the event sources and the event types, there's a lot of different choices here that we'll go through as well. And you also have a lot of choice on how those events get delivered to your services. Now, the terminology of Knative Eventing is that, first of all, you have cloud events. So this is the format of the events that we'll talk about. Then you have event sources. So who is actually creating the event, or where are we pulling events from? These are the event sources. Then once the events get into your cluster, they go to somewhere called broker, which is, it's a place that gets the events within your namespace. And then from the broker, you want to send the messages to your services, but you define that through what's called triggers. And then finally, you have services receiving these messages, Knative or Kubernetes services. We'll go through these one by one and look at them in more detail. Finally, there's also channels and subscriptions, but we don't really need to worry about this too much. There are things that are created under the covers, but once in a while, you might need to look at them. So that's why I will mention them briefly here. Now, first of all, as I mentioned, the format of the events is cloud events. And cloud events, it's an open source eventing format from CNCF. So you can check it out in more detail at cloudevents.io. And these cloud events, they basically define a kind of high-level event definition, right? For example, when you look at cloud event here, it has a spec version, which is the version of cloud event. 1.0 is the version. Then the event type and the event source. These are the things that you need in any kind of eventing system. Then you have the typical things like the ID and the time of the event. And finally, the data of the event is the thing that holds the actual payload. So for example, in here, we are listening FTP, GitHub, Google Cloud Storage kind of events. They all come in, they all get converted into cloud events, and the data field will have the actual event that you're interested in. And then when the broker gets the event, it will get it in that format, right? And I should also mention that Cloud Events has SDKs to actually read and write events. So if you want to use them, you would start with SDKs. And Google Cloud also has libraries to parse this data field, right? So if you're reading, say, Google Cloud Storage event, you would use this Google Events libraries to parse that event as well. So that's the format of the events. But what kind of events we can listen? Well, basically, there's a lot of different kinds of events. So you can listen AWS events. You can listen Google Cloud PubSub events, Google Cloud Storage events. This is not the full list. You can check this link for the full list. But there's a lot of different event sources that you can install and list and pull messages in to your cluster. You can also write your own event sources. So if you have something custom that you want to read from, you can write your own custom event source. Now, once the event gets into your cluster by the event source, it gets to a broker. A broker, it sits in the namespace. For example, in this case, we have a broker in the default namespace. It has a default URL within the cluster. So people within the cluster, not people in the services within the cluster, they can send messages to this broker, and the broker will distribute those messages if you want. Or you can configure event sources to read the events and pass it to the broker. So it's a way to kind of get events into your namespace, and then from that namespace, you're going to distribute them to different services. And by the way, usually the broker is injected into your namespace. So you label your namespace with this label, namespace injected. And then that will kind of inject the broker into your namespace. Now, once you have the messages in the namespace, you create a trigger, and trigger defines what kind of events go to what kind of services. For example, in this case, we are defining a trigger, and then we are filtering on these messages, and the message type is Google Cloud Storage Object Finalize. So these are Google Cloud Storage events. And then the subscriber, it's a service, it's a Knative service that's called filter. So all the messages from Google Cloud Storage will go to a Knative service called filter. So that's the kind of things that you can do with the filter. And then finally, you have to define a service to receive the message. This is typically a Knative service, like I am doing here. But then if you change the API version from Knative API to Kubernetes API, it can be a Kubernetes service as well. It will just receive the event, and it will either consume the event, or it can also consume and reply to the event. And that reply will go to the broker, and the broker will kind of send it to other people with the other triggers for that message. And as I mentioned, channel is something that you don't necessarily define or change every day, but it's something that you need to think at the beginning of your eventing pipeline. Channel is the persistence layer. So as services go through your system, how do they get persisted or not? That's what channel defines. For example, in my demos, I'm using in-memory channel, meaning everything is in memory. So if something goes wrong somewhere, like if my broker goes down or if my service goes down, I'm going to lose the messages. But it doesn't matter to me because it's a demo. But in production, you probably want something more durable. So there are things like Kafka channel, there's Google Cloud PubSub channel. These channels you configure, and then you set them as default channel to your broker, so that by default broker uses these channels instead of the default in-memory channel. And then there's subscriptions. These are kind of things that get created under the covers. So when you create a channel, and then when you have services connected to that channel, then behind the scenes there's subscriptions that's been created. Triggers also, they create subscriptions behind the scenes. You don't necessarily have to worry about this so much unless you're using old way of sending messages. And I'm going to mention this as we go along on how we deliver messages, but it's not something you typically need to worry about too much. All right, so we defined the building blocks of Knative Eventing. Now let's look at how you can actually send messages through your system and what kind of methods you have for that. There's actually a few different ways, and I kind of grouped them in different headers. First is the simple way of sending messages. Second is the complex way with an optional reply. And the last one is broker trigger delivery. Usually, broker trigger delivery is the one that you should care about. The rest of them, they don't really have anything more than broker trigger delivery provides. But I want to mention them as well because they might be useful in certain use cases. But typically, you would just inject a broker and create triggers from it, and that should be enough for most use cases. But let's go through them anyway, just to take a look. Now, in simple delivery, you basically have an event source, and then you will have a service, let's say Knative service, and you just connect them together, right? It's the simplest way of sending a message from source to sink, in this case, a service. This is simple, meaning there's not much to worry about, but at the same time, it's very limited. First of all, you can only do one-to-one, so you can have one source to one service. And secondly, there's no way to do to change the event what do you say the event persistence, right? Because here, if the source goes down or if the service goes down, this message goes down. There's nothing in the middle that will kind of persist the message for you, right? So it's for very simple use cases where you don't really care about what happens to the message and you just want to connect source to service right away. It's for that. It can be useful, but the use cases are very, very limited for simple delivery. Now, if you want to do one-to-many, then you need to start thinking about channels. So in this case, you have a source and you have a couple of services that wants to receive that message. Now, instead of connecting source to the service directly, what you need to do is you need to create a channel. This can be an in-memory channel or Kafka channel or whatever kind of channel you want. And then from that channel, you need to create subscriptions for each service. And then when a message comes in, it will be fanned out to multiple services. This is more complicated in the sense that you need to create these channels and subscriptions manually yourself. But it gives you more things, like it gives you fan out, first of all, so you can fan out messages. But it also gives you a way to persist messages at the channel if that's what you want. Now, these services, they can also reply back to messages. So in this case, for example, we have source sending messages to a couple of services, and then service 2 replies back with the message, right? So when it receives a message, it will reply back. Then you can route that message to the subscription, then it goes to the subscription, and then from then you can route it to another channel, and then that channel can go to another service, right? So, this is more complicated, but it allows you to do more complicated architectures this way, which is good. But at the same time, it's also kind of getting hard to set things up, right? So here, for example, we had 3 services, and we need to create 2 channels, and we need to create 3 subscriptions, and we need to make sure that everything is hooked up correctly. So it can easily get out of hand if you have, like, say, tens of services. It can be easily, like, you can easily kind of get confused between different channels and subscriptions and things like that. So that's why we have this thing called broker trigger delivery. And this is the latest way of setting up messaging in Knative. And it's the one that I recommend. Now, in this model, what you do is that you have your source, and then you inject a broker into your namespace. And by default, source sends messages to your broker. And then from the broker, you create triggers. So each service kind of specifies what kind of messages I'm interested in from the broker. So service 1 and service 2 will say, I'm interested in this kind of messages. And then each service can reply to the message. So in this case, service 2 is replying to the message. But then because of these triggers, they filter these messages. So when this service 2 replies to this message, it doesn't go to service 1 because service 1 will only get this kind of messages. Then service 3 will get the red messages because that's the type of trigger it has. So when you look at this, actually, it's the same use case. So what we are doing here and what we're doing here is the same thing. But here it's much easier to set up because all you need to do is inject the broker. So you do that once in the namespace, and then you just create triggers with the broker. So this is a much easier way of kind of setting up eventing in Knative Eventing. All right. And then what I want to mention, Well, first of all, I need to mention that I have, if I go to my Knative tutorial, I have examples of this simple delivery, complex delivery, complex delivery reply, and broker triggered delivery as well. So all of these, you can run examples of them as well if you want. But I'm going to show you a more complicated example shortly. So because of that, I don't want to show these examples right now. So let's just talk about one more thing, and then we'll look at a more real-world example of how to set things up. Now, as I mentioned, Google Cloud has different kinds of event sources to read Google Cloud sources into Knative. These are all defined in a project called Knative GCP project. And in this project, there's a number of event sources. There's, for example, Google Cloud PubSub source. That's for reading PubSub messages into Knative cluster. There's Google Cloud Storage source to read Google Cloud Storage events into your cluster. There's scheduler source to kind of create Google Cloud schedules that run on a certain schedule and call certain services. So you can set that up with Google Cloud Scheduler source. So these are very useful. Basically, if you're in Google Cloud and if you want to read Google Cloud sources, you can install them and then they let you read these events in an easier way. And that's what I'm going to use in my demo that I'm going to show you. Now, this demo that I want to show you, it's a BigQuery processing pipeline. And what I wanted to do is that, I'm based in London, and we started having lockdown in mid-March. We all started working from home. And at the time, COVID was a new thing, so I was checking the number of cases in London every day. At 4 or 5 p.m., I would check out and see what were the numbers for the day. So after like a week or two, I thought to myself, instead of me checking these cases by myself, why don't I build a pipeline that would check these numbers for me, and then it would send me an email every day at a certain time with the latest numbers, and maybe it will send me a chart as well. So I basically wanted an easy way to see the numbers for every day without me having to check for it. So that's when I started building this pipeline. So the way I built this pipeline is kind of like this. First, I said to myself, okay, how can I get this data? Where can I get this data? And in Google Cloud, there's something called BigQuery. BigQuery is a data warehousing solution. And the good thing about BigQuery is that it comes with lots of public data sets. And one of those, not one, but a few of those data sets is related to COVID. So what I did is first I built a service called Query Runner. This is a Knative service that will go to BigQuery and it will ask BigQuery using the COVID data set, what are the number of cases for this country in the last month or so, right? So it will query that, it will get that data, and it will save it to a temporary table. You can create temporary tables in BigQuery, so I will ask to BigQuery and save it to a temporary table. So that was my service number one, but I wanted this service to be triggered on a schedule, so I used Google Cloud Scheduler to trigger that service once a day at 4 p.m. for United Kingdom, for example. Now, once I make this query and save it to a table, I send a custom event. So I reply back to broker and say, okay, I run a query. So I just reply back with a custom event that goes to another service called Chart Creator. It's a Python service that will read this table and it will create a chart from it using Matplotlib library, right? So it will read this table, create a chart, and it will save it to a Google Cloud Storage bucket. And then I set this bucket so that when an image is saved here, a chart is saved here, it will call another service called Notifier, which is another Python service that will use SendGrid to send me an email. And it will say, okay, there's a new chart created in the storage. Here's the link to go and take a look, right? So the good thing here is that it's event driven. So the scheduler triggers the event, and then that triggers the whole chain. But none of these services, they know each other. The query runner just runs the query, then sends a message back to broker, and then that goes to chart creator. All it does is, it kind of just reads the table and creates the chart, so it doesn't know that there's a query runner. Similarly, notifier, all it cares is that there's a new chart in the bucket, so it gets a notification of that. So the whole thing is loosely coupled, event-driven, and in the end, I get an email at the end of the day. So let's actually look at this in detail. So first, let me show you the code, not the code, but the configuration at least. And the code is on GitHub, by the way. So if you look at BigQuery, first what I need to do is I need to create scheduler sources. So in Knative, there's, as I mentioned, in Knative GCP project, there's different sources. So in this one, I'm saying I'm going to use cloud scheduler source, and it will be triggered every day at 4 p.m. and it will send a message to the broker with this data, and the data is United Kingdom. And my broker will pass this to my query runner, and query runner will get this United Kingdom data, and it will say, okay, I'll ask BigQuery what's the numbers for United Kingdom is. So that's my scheduler source. Then the storage source is my charts. Once I say my charts, after the chart creator says the charts, it will send a message to the broker, and the broker will get the notification that there's a new chart in this bucket, right? So these are a couple of my sources. If you look at the query runner, I mean, the code itself, we don't have time to go through it, but basically it gets the cloud event. So this is the event reader that I created. It gets the cloud event, then it extracts the country from it, then it runs a BigQuery job, and then once it does that, it sends a message back to the broker that I run this job, and there's a new table. But the interesting thing is to look at the KtoService. So the KtoService is the query runner that just points to the query runner container, and the trigger, it triggers on filtering on job scheduler. So it only looks for cloud scheduler events. So only triggers on the cloud scheduler events, right? So that's query runner. Then after that, it goes to chart creator, and chart creator, we don't have to look at the Python code, but if you look at the trigger, the chart creator will only look at the query completed custom message, right? So this is a custom message that the query runner will emit, and then it will go to this chart creator. And then similarly, notifier will only trigger on object finalize. So whenever there's a storage bucket update, it basically will emit this storage object finalize event, and this is what the notifier will get, right? So let's actually set this up and see if it works. So let me get out of here and go to Eventing, Processing Pipelines, BigQuery. Now, I think I can get rid of this. Okay, so let's make this a little bit bigger. All right, so let's first create the scheduler source UK. So this creates the cloud scheduler source for UK. And then let's also create the storage source so that when we say the charts, we get those events as well. And then we will get into query runner, and then we'll create the Knative service and then the Knative trigger for that. And then let's do the same for chart creator. And then let's do the same for notifier. All right. So if everything goes well, we can look at our services. So you can see that we have 3 services that's been created, and then we can look at the triggers that's been created. And the triggers, they are being initialized. They will talk to the default broker. And I already have a broker injected into my namespace. So the default broker is there. And let's also look at cloud scheduler source. So this is the thing that will trigger the events. And then cloud storage source is the thing that will trigger storage events. So everything seems to be set up. Now we can wait till 4 p.m. for it to be triggered, but we can also manually trigger this event. So if I do gcloud scheduler jobs list, we can see that there's a job that's been created that will trigger at 4 p.m. But let's actually trigger this ourselves. So if I do jobs run and then pass in the ID, this should trigger the job now, and then now the whole event chain is being initialized. So if everything goes well, this will go to the query runner. Query runner will actually run the query, and if you actually look at the logs, you can see that we have the services running. So let's just take a look at the logs of query runner. Oh, sorry. Yeah, the query run is actually terminating because they scale down, right? So if I look at pods again, you can see that they scale down. So I couldn't see the logs, but I think the whole thing ran. So if I look at my email, you can see that I got an email, a new chart from BigQuery pipeline, and if I open it, I have a link to a chart. A new chart is available. Let's just take a look. You can see that I can see the COVID cases in United Kingdom. That I get the chart, from the beginning of March till today. So that's it. Hopefully this was useful to you. As I mentioned, the presentation is already on speaker deck, so feel free to get it there. My Knative tutorial on GitHub, it has many more samples than I show you today. Hopefully the samples that I show you it was useful and you have an idea on how Knative works. Also, as I mentioned, Knative, if you want to run Knative on Google Cloud, you probably want to use Cloud Run. And I also have a Cloud Run tutorial on GitHub for that as well. So feel free to check it out. Thanks for listening. And if you have any questions, feel free to reach out to me on Twitter. I'll be happy to answer. Thanks very much.
Thank you very much, Matt. It was really very interesting and useful speech. Matt, you and our participants, I invite you to our Zoom room to discuss all interested questions.